Great. Thank you, Keith. Well, as Keith mentioned yesterday, we touched on a few things. Keith talked a little bit about the changes over the last 20 years, both in the business environment and in the personal environment of technology. Thomas talked a little bit about the business environment and the changes that are driving the digital transformation and the expectations for manufacturing. $4 trillion worth of expected value over the next 10 years. And then Jan talked about what the connected enterprise looks like and the pieces, so that you could go out and see kind of the latest pieces of the connected enterprise over these days. Today I'm going to talk about the journey. And to do that, I'm going to talk about three things. I'm going to tell you a little bit about our journey. Rockwell Automation was an earlier adopter of this technology, and so I'll tell you a little bit about our lessons learned. We'll talk about some specific examples of value. Where have people found the value of the connected enterprise? And then we'll talk about planning. How do you get started? And some thoughts around how do you structure a connected enterprise project. It all starts with data. The movement of data between devices, systems, people, and back. And the reason that that data is so important because, of course, it allows us to go and make decisions, perform analysis, and track our performance. And when it's not there, the decisions become slow, incorrect. And when I'm talking about decisions, I'm also talking about both decisions that we make and the management makes, but also the automated decisions within the system. And it's interesting because in some parts of our lives, we have become so accustomed to great data. But sometimes in the manufacturing environment, we've become used to not having good data. And it's not until people go to a facility that's really starting to push that they see what they should expect now, because it's changed. Sources of data. There's two big sources of data within a manufacturing environment. On the left, you have ERP, which is the biggest piece or the backbone of your business application layer. You might have other systems like PLM and some of those other systems, but your ERP system has your bills of materials, routing, standards, specs, and is a huge source of information. The other source of information is on the shop floor. The devices, the PLCs that are controlling the tasks that are occurring every day and collecting that information. And they're not connected. They're almost two islands. If they are connected, it's usually done at a very light level. A typical way to connect them is the use of a middleware or MES layer, a manufacturing execution system that allows us to go and pull the information from the ERP level, the business process level, and the task level from all the devices, pull it into that center, and provide us with the ability to provide manufacturing process control. So on the one side, you have the business process management. The other side, you're controlling the devices and the individual tasks. But then you can combine them to go and provide real-time manufacturing process control. To start a journey like this, we're talking about a solution. But first of all, you have to define the problem. And this is probably the most critical piece of the connected enterprise journey, and that is defining the issue that you're trying to solve. Determine the business drivers and strategy. So when we talk about different industries and companies in different industries, they have different drivers. If you're talking about oil and gas and chemical, you're talking automotive, heavy capital intensive, OEE, uptime, critical drivers. If you're talking about wire harnesses, and assembly operations, it's labor productivity. If you're talking about pharmaceuticals, it's around compliance and tracking of information. And different industries have different business drivers. And one of the things we have to do when we have a technology solution is look at which business drivers we're going to improve and move the business forward. Once we've identified those business drivers, we've got to put together a project plan that has phases that cost justify themselves. You might get a little bit of leeway with respect to the first phase to go and get some upfront capital to do a project, but after that, you've got to pay for it. And to do that, you've got to put together a large project into a series of phases that pay for themselves. And when we talk about paying for themselves, we're talking about return on investment, ROI. And typically, you need to have a good ROI to move ahead with these projects. Some projects are going to be strictly strategic. I mentioned pharma. Some of the early adopters of this type of technology was done because of regulatory. You had to be able to meet certain compliance requirements, and so it was just non-negotiable. And so pharmaceuticals is one of the groups that is further along the journey. Areas of value. And I'm going to go and give you examples of all of these areas of value as we kind of get a little further into the discussion. First one, accessible information. We have to have accurate data that's accessible and that can be communicated. So we've got to be able to go and have the accurate data and be able to disseminate it to anyone who needs it. Work order control. That's the idea of knowing the tasks and the jobs that are flowing through your manufacturing environment and capturing all the relevant data for those jobs and controlling them. Process control, real-time process data. The typical example is quality data, talking about it at the end of the shift at a manufacturing line to look at what happened during that day, as opposed to real-time with the data and the details. And analytics. And when we talk about analytics, we're talking about three things. We're talking about access to the data. We're talking about being able to put together data from different sources so it makes sense, and then perform higher level analytics. And there's a tremendous amount of work, and we're doing a tremendous amount of work in that area right now. So I'm going to tell you a little bit about Rockwell. Thomas mentioned yesterday that we started this journey around 10 years ago, and I'm going to tell you a little bit about our journey and some of the lessons we've learned and some of the applications. Right now, we have 14 facilities that we consider to be part of the connected enterprise, and that includes 400 manufacturing cells around the globe. This journey for us started around 10 years ago, and Rockwell has been around for over 100 years and has a long history of being a solid, profitable, good-performing company. But 10 years ago, we looked at our performance and we said, this is not at the level we want to be at. Our quality levels were not at the level. Our delivery was in the low 80s. Our inventory was running around 120 days. And so we came back and we said, hey, we're going to set our goals and we're going to go and change the way we do our business. So we started with those business drivers. Where do we want to be on delivery? Where do we want to be on quality? Inventory, OEE, and we set those goals. And we started. And one of the first things we did was we looked at our landscape and said, okay, we have all these facilities, and in our case, we had multiple ERP systems, and if we did have the same ERP system, it had multiple instances. And one thing, just to step back, every operation has its own type of complexity. For Rockwell, it was product complexity. 387,000 SKUs. Every one of those SKUs having a bill of materials, so you have millions of parts coming through, tens of thousands of suppliers, manufacturing in 20-odd facilities around the world, and shipping to tens of thousands of end destinations. And so complexity was one of the items that we had to wrestle with. So one of the first things we did was we went to a standard ERP system globally. That's a big project. As part of that, we soon realized the need for having that shop floor data. And so we rolled out that SAP with an MES layer. So we did them jointly. And also as part of that transformation, we consolidated our supply base. So we consolidated our number of vendors, the number of manufacturing, and one of the things we were doing was we were simplifying our system. One SAP system, one MES system, and a consolidated group of suppliers. So what was the approach? First of all, you have to have a plan. So we put together a 5-year plan, which is really the length of our strategic business cycle. And we talked about a 5-year plan. That was estimated capital per year and expected performance per year. Was it 100% accurate? No, but it was the beginning and that was the plan. We mobilized teams. Very often on a project of this size, people start as a small group that is part-time. And when you're talking about projects like this, it requires dedicated resources to plan, dedicated resources to execute, implement, and then maintain. And I'll talk a little bit about how we're structured now a little later. One of the very important things for us was to develop the detailed playbook. One and only one way. I told you we were trying to deal with complexity. So when we did our SAP implementation, we talked about global business process owners, one instance, and aligning on one way. Now, there's a lot of complexity, so when I talk about Rockwell, there's make to stock, assemble to order, make to order, configure to order, engineer to order. So we have all sorts of variants, but we do it with the same basic process globally. We also rolled out the processes in a very similar way. So when we came in and we implemented SAP and MES, we used the playbook. And of course, the outcome of that is more standardization on best practices and also less customization. It used to be that customization was a great word. You always wanted to have everything customized. Until you realized that customized meant that you were doing the same thing 30 different ways. It was coded 30 different ways. And every time you upgraded it, the testing and implementation was horrendous. And so we found that that standardization has paid tremendous benefits for us. Well, what does the solution look like in Rockwell? What you're looking at here is along the bottom, you have all the devices. You've got sensors, PLCs, individual pieces of equipment, control layers. At the top, you have the business applications, whether it be ERP, financials, PLM. And then we wanted to connect the two. And so what did we do? And this is really what our solution looks like. You have the data collection. It's pulling information into what we call the MES, which is our factory talk production center, using a standard Ethernet network. On top of that, we have Vantage Point for dashboarding and being able to share the information, as we also use the cloud platform for mobility and at the enterprise layer. So we're pulling all that information from the devices, and we're pulling down the information from the ERP system and the business application, and of course, it's two-way communication. So what does it allow us to do? So you have a dashboard. So what's interesting about this dashboard? This dashboard is from our SMT line. I told you we have 400 manufacturing cells. We have approximately 20 SMT lines because, of course, we do circuit boards, and that's surface mount technology. So we have around 20 of them, and they're spread across 4 facilities. And this particular snapshot is of an SMT line in Singapore, one of our facilities. And it has OEE on the top with month, week, and this shift. And it also has components per hour and some analytics. Now here's what's different. This is real-time data that you can get to anywhere in the world. So if you're in the plant, you can pull it. If you're a director of operations in the region, you can pull it up. If you're the VP of ops, you can pull it. You can pull it when you're traveling. The other plants can pull it. And now let's compare it to how most facilities will do something like this. OEE is always a little bit of a nuisance to calculate anyway. But you think about going into a factory and you go and think about the cells, and there's usually a downtime report. Somebody's put down the production numbers. There's a quality report. And at the end of each shift, people gather the papers. They drop them off on somebody's desk who puts it into a spreadsheet, and they do the calculations for OEE, and they do it differently. And then you roll that up by shift for 400 cells, and then once a month, some poor guy or gal at the head office has to put it all together and come up with the global OEE number. And they email it out to everybody. And everybody, when they get that number, knows that those numbers are not comparable between plants, and they're really only an indicator of whether that facility that you're looking at has gotten better or worse, because the numbers aren't the same. This changes that. This data is getting pulled right from the equipment. It's going through one definition of OEE that's calculated one way, and it's distributed globally. And it's not done once a month. It's done in seconds. So if you make an improvement and you want to see how it's going, and there was a change on Sunday and you want to see, oh, on Wednesday, hey, how's it going? You don't have to wait for next month to start getting the reports. You can see it immediately. Well, let's take this a next step. So the last slide I showed you was OEE. We're staying with the SMT line. So again, same 20 lines globally. Same thing, we're reporting quality globally. And in this particular case, what you're seeing is internal PPM, or internal defects, across those 20 lines in 4 facilities. And what you see is you see a nice improvement, approximately a 40% improvement over 2 years. And that's a nice improvement. But really the interesting thing was how easy it was to do it, because this was best practice. Once you had standard numbers, you've got similar processes with similar equipment globally, and we had one facility that was running at 8,000, and we had another facility running at 2,000. And so you don't have to do high-end analytics to say, hey, there's a difference there, I wonder what it is. And so this improvement was driven by best practices. Hey, who's good, who's not so good, what are the differences, and how can we implement them? Some really nice things about that. Not a lot of capital, because it's already being done. The testing process is pretty short. If you do a new process change and you think about wanting to go and make sure that you fully tested it out, but if it's already been in production in another facility for a couple of years, it's pretty easy to roll out. The idea of standard real-time information collected in a similar way that allows this information to be communicated and the group to work as a team rather than individual sites. Jan mentioned this yesterday, and I'm just going to spend a second on it. I've been talking at the macro level between plants. The same technology and the same communication can occur within a facility for specific problems. And the idea of getting accurate data out quickly is the key. And if you think about a regular plant, you have an operator, they're running something, and there's a problem. Maybe the equipment goes down or it's not cycling correctly. They may tell their lead, who radios the maintenance guy, who will come over, decide he needs to bring his laptop and see what's happening, might pull down some fault codes, and 30 or 40 minutes later, you may have an initial diagnostic based on some fault codes. He might decide that he needs to get a process engineer in. The same thing can happen with respect to having those fault codes sent immediately to the maintenance person, who can look at those and say, maybe I need to have that process engineer right away. And so instead of going from a 40-minute average response time, you go to a 25-minute average response time. Same information, but it's accurate the first time, it's communicated to the right people the first time, and people can make decisions. When you go in a facility, and I spend a lot of time in manufacturing facilities, it's very normal to see a production line, and at the end of the line is a whiteboard and maybe a little table. And on that whiteboard, you're going to see a little table, and it's going to have the part number, and it's going to have your hourly goal, and it's going to say, what did people actually do? And then on the table, you're going to have a downtime report where people fill in, what happened on that shift, and a quality report. And so to go and figure out what has happened, you've got to spend some time out there, read the data, and you find out at the end of shift. On our 400 lines, each one of these lines has a display like this. And I'm going to walk you through it, so it's a little difficult to see. In the top right is that hourly production. And the goals can be pulled down from the recipe or can be pulled down from your ERP system and populated. The actual performance is pulled directly from your equipment and is real time. So it's accurate, it's done immediately, and it can be communicated, because this same table, which is on a screen above every line, can be pulled and looked at a desktop. If you're remote and you want to see it, you can pull it and look at it from there. And you can see every time you have a poor hour or a good hour. Right underneath that is downtime. Those green lines are actually downtime events that have been fixed. So it has an open time and a close time, so you know exactly what had happened. And this is, for those of us who spend a lot of time in manufacturing, those yellow are really interesting because they're running impaired. That says instead of the equipment running at 20 cycles a minute, it's running at 17 cycles a minute. One of the most insidious ways of losing production and OEE is not running at rate, and you don't see it. When you walk by a line, if you're a supervisor or an engineer, you walk by a line, very few people can tell the difference between running at 17 and 20. And so by the end of the year, it just kind of gets all washed in there. So this only also tells you you're not running at rate. So anybody walking by can go and say, hey, why? Let's troubleshoot that now. Below that is the schedule. You might take that from your ERP. You may take it from another optimizing piece of scheduling software. Top right, all the order information. What are you making for who? And you have the information on the top left. Bottom two items are quality data. And when we talk about quality data, those are actually fault codes from test equipment and tell you exactly when and where they happened, and then underneath it's the history. All real-time data, all available to the operator, all available to the supervisor, all available to the team. Oh, and one thing I should mention, you can also have alerts sent from this. So if all of a sudden, people often will say, if you want to escalate, if something's down for more than 5 minutes or 10 minutes, I want to know about it, well, you can set up alerts so that people get texted or emailed. And you'd be amazed at how many supervisors will say, I want to know within 5 minutes. And then they start getting all the texts and emails, and they say, well, maybe 10, 15 minutes will do right now until we get a little bit better. Now, I love this example. This is around process management. We make a lot of electrical equipment. And one of the issues, of course, is you have to make sure your wires are properly connected. And on this particular line, at the end of the line, we would do the tests. And one of the things we might get is we might get a fault code. And the root cause very often was loose wires. So you've got to diagnose it, you've got to tear it back down, fix it, rebuild it, retest it. And of course, the chances of having one go out into the field, if it's getting to our final test line, is higher. So we wanted to go and deal with this. So what you're looking at on the left is the actual operator station where they're going to attach some wires. The picture you can pull down from your PLM, PDM, ERP, and it's a picture of that. And you can see underneath that it's got the 3 wires actually identified. And what they're going to do is they're going to use a torque gun to put in those 3 screws to attach it. So that's the picture in the top left. You have your ops pulled from your routing, probably from your ERP. You can have route specifics underneath that. The order number, the piece in the yellow, is all the details around that unit. These units are all serialized. All the data, all the materials going into that unit, we have traceability for. So if you fall and you say it was this number, we know what day, what line, what operator, and what pieces went into that piece of equipment. Underneath is, and this is kind of the neat part, is actually the display from the equipment that's doing the torque gun itself. And what it's measuring is it's making sure you've got the right head in there, the number of times it's screwed in, and then the torque. And it measures it, so those torque readings are, again, collected and serialized to that unit. If it does not meet the spec, you cannot move that piece of equipment forward. It has to pass it. You might take it offline, but until it passes, you can't move it forward. And the nice thing about that is that's about using technology in a different way just to take care of a problem. How would you have done this in the past? I know when I ran plants, I used to go and see corrective actions that finished in retrain operator. Somebody missed it. Well, if you're doing this hundreds of times a day, it's pretty easy to miss it. And so now what you've done is you've automated it, you've foolproofed it. And the one other thing about this station that I should let you know is when the operator logs in, if they're not trained on that station will not cycle until a supervisor comes in and overrides it. You don't have to do that, but if training is important for you at the different stations, it's another fail-safe that we put in. The last piece, analytics. One of the hardest things, kind of for the technical staff, and you think about a quality issue, is to piece together a quality complaint with an order and with the environment on the floor when it occurred. What we've done is we've connected all of this so that you can go and have access to that information. You know the order, you know the serial number. So now all of a sudden, just through drop-down menus, you can pull the part number, serial number, and you can go and pull it against what the operating parameters were at that time with some simple analytics. And do you remember I said there's three pieces about analytics. One is getting the data, and then two is getting the data so it matches, so it's contextualized. This goes a long way to that number, that second issue. Thomas showed you this slide yesterday. And by the way, if you're wondering what the picture is, that's our head office in Milwaukee. And we've had some very significant improvements because of this. We've had a 50% reduction in quality. Our on time has gone from the low 80s to the high 90s. Inventory reduced from 120 to 82 days, and CapEx reduced by 30%. So let's just kind of talk about some of those items. CapEx, we need less equipment because our OEE is better. Why is our OEE better? Is because when we're not running at rate, we figure it out. Our defects are less, we catch them quicker so we don't have to go and rework them. All of those sort of things. Our labor productivity is tracked. Only trained operators work on it, and all those things go into OEE. So we buy 30% less equipment because our equipment is running more. If you think about those same impacts on delivery and inventory, when you have quality issues, you end up with the rework, you end up with late on time, and you end up having it sit in your inventory. The number that we're probably the operations team is most proud of, though, is that productivity number. Our year end finished at the end of September, and we've just started our new year. And I happen to know that that number for this past year is closer to 7 than it is to 5. And one of the things we've found is that year over year, our productivity has improved. And one of the reasons is because of the idea of the best practices in the network getting larger. Gartner put out a report recently talking about MES implementations. And one of the things that they said was larger installations with multiple sites have seen better benefits. And so you can go and get benefits at an individual plant level, but we've also seen it take off very nicely because of the network. Was everything easy? No. Some of the issues we discovered, people. The people who are used to working in this environment have different skill sets than what may have been there before. And so finding the right people and getting the right teams is something you have to plan. The other thing around people is there's a tendency to say, I want my MES expertise and I want my data scientists to be at every plant. And we found that expensive. So we have an MES Center of Excellence. So we have a core team that deals with our MES globally, and then we have people who do execution at the facilities. We have a core group that does data scientists who look at our issues and pick the problems to go into it in detail with data analytics. And they're centralized because the cost of having them at individual facilities working on potentially redundant problems across plants was something we discovered. The issue on both process and technology is very similar. And I mentioned it before. It was standardization. If you don't standardize, the complexity in your system, in your software, can become problematic. Leadership. This is not an initiative where the leadership says, hey, go do this and let me know when it's done. Our senior vice president of operations led monthly meetings for 7 years on these issues, following it, tracking it, and making sure that it gets implemented. So when you had to standardize on an OEE calculation, you had the guy at the table who could call and make the decision. When we were identifying problems to prioritize, they were prioritized. And so the idea of a regular standing meeting with leadership to continue to drive this process was one of the key things that we found to drive success. Here are some of the key takeaways from our learnings. Senior management sponsorship. You can't do an enterprise transformation at the plant floor level. Don't underestimate the culture change. You're solving problems with different tools and a different mindset. Have a plan. The connected enterprise isn't just going to evolve. It's got to be purpose-built. Create a win. Early successes make the project a lot easier, tied to a business strategy. This is a business-driven capability. Focus on critical KPIs, and the never-ending journey. This isn't something that you set up and leave. This is such a dynamic area right now in the economy with respect to analytics, tools, new products. You're constantly revisiting this. So I've told you a little bit about our journey. Now let's talk a little bit about people who are starting their own journey and some fundamentals. Keith mentioned that I get the opportunity to work with a number of our clients as they start their journey. And there's some fundamentals that are taken, you always have to kind of hit. One is evaluating the business. What are the key drivers and what is the leadership team trying to do? So is it labor productivity? Is it quality? Is it compliance, inventory, materials management? You need to know those top few items that you're trying to fix, because that's what you're trying to fix. You're not trying to just implement technology, you're trying to fix a business problem. The strategy, and this is important for me, is a company trying to change its strategy? We went from decentralized to centralized. You need to know that before you start designing. Or is it the same strategy where we're going to say we're going to remain this way, but we want to get a lot better? Those are two different solutions. Technology evaluation. You've got to be clear on what your installed base is like, what is the equipment on the floor, and is it capable of doing what you need? Is your network at the plants and between the plants capable? And do you have the software and business applications that you need? Right now, I have a client, and they have a major ERP system, but they didn't implement all the modules, and so they have some limitations in their capabilities. And so we're working with them right now to go and think about what are those capabilities and how do they want to bring them on. Organizational evaluation. You have to have alignment amongst the leadership. And when I talk about the leadership, it's typically your ops and IT groups, and they have to have alignment. It's not either or anymore. It's got to be both. And typically also your engineering and finance groups may be involved. You may have one champion, but this is a cross-functional initiative. You got to be realistic about the technical capabilities you have within your firm, and what do you need to reach out to augment your firm with. If you haven't done this before, it's unlikely you're going to have all the capabilities. And change management. This is a typical approach to putting together the plan. You start with the strategy. What are people trying to achieve? What are the metrics that you're trying to do? And get alignment amongst the leadership. Opportunities. We typically go out to the facilities, and we're out there looking to go and see where the quality opportunities are, the material opportunities, the inventory opportunities, the uptime, downtime, to go and say, hey, how much do we think we can improve? The cost estimates are based on what do your assets look like? What's your network like? What software do you have? And once you get those two pieces of information, now you can put together the business case and then a roadmap. And for a single site, a roadmap can be anywhere from 6 to 15 or 18 months. For a multi-site operation, you're usually looking at 24 to 48 months to really get something going. Some last thoughts. The critical few. Know the business drivers and have alignment with leadership. Understanding your organization's capabilities and understanding your technical capabilities out on the shop floor. If you truly have those three things buttoned down, you're off to a good start. Well, thank you very much. I'm going to pass it back on to Keith to go and tell you about some of the exciting things that are going to be happening later today. I think we have EdFest tonight, and so we're very much looking forward to that. So thank you.
Thank you.